In this lesson, we'll discuss how to write electron configurations of ions. Writing electron configurations for ions is very similar to writing electron configurations for atoms, but with a few minor adjustments. We'll start with drawing electron configurations for negative ions. To do this, the first step is to draw the electron configuration of the neutral atom. From here, you simply add the correct amount of electrons to the appropriate orbitals. Let's look at a chlorine ion as our example. First, we must write the electron configuration for the chlorine atom. From the periodic table, we can see that the abbreviated configuration for chlorine is the same as neons, followed by 3s2 and 3p5. Now, the chlorine ion has a charge of -1, which means it has one more electron than the chlorine atom. Since we have one spot left in the 3p subshell, as there are currently only 5 electrons in that subshell, our added electron will go here. Thus, the configuration for the chlorine ion will be the same as neons, followed by 3s2 and 3p6. Now let's look at drawing electron configurations for positive ions. Once again, you begin by writing the electron configuration for the neutral atom. From here, you begin removing electrons from orbitals with the largest n. If there are 2 orbitals with the same n that you must choose between, choose the one with the larger L. Let's look at the sodium ion as an example. Once again, we'll start by writing the configuration for the sodium atom. From the periodic table, we can see that the configuration for the sodium atom is the same as neons, followed by 3s1. Now, since the sodium ion has a charge of +1, this means it has lost 1 electron. From our configuration of the sodium atom, we can see that this electron must come from the 3s orbital. Thus, the configuration for the sodium ion is equivalent to neons. Let's look at one last example of a zinc ion. Once again, we start with the configuration for the zinc atom. From the table, we can see that the configuration for zinc is the same as argon's, followed by 4s2 and 3d10. The zinc ion has a charge of +2, which means it has 2 less electrons than the zinc atom. Now, it might be your first instinct to remove the 2 electrons from the 3d subshell, as that's the subshell that was filled last. But remember, we must take electrons out of the orbitals with the largest n. In this case, the 4s subshell has a larger n than the 3d subshell, and thus we remove the 2 electrons from the 4s orbital. Thus, the electron configuration of the zinc ion will be the same as argon's, followed by 3d10.